Hello and welcome to IC&D1 Lab 8. This lab explains how to configure static routes as well as the requirements for connected routes to show up in a router's routing table. If you're using the Cisco Press exam certification guides, note that the IC&D1 book, Chapter 14, introduces both of these concepts. Let's look at the objectives for a moment. By the time you're done with this lab, you should be able to better explain the concept of a connected route. In particular, you should be able to list the requirements that a router has before it will decide to add a connected route to its routing table. You should also know a lot more about the IP route command, which a router uses to configure static routes. In particular, you'll be able to better configure it using both the next hop IP address option as well as the outgoing interface option. It's just two different styles of configuring a static route. Now along the way, the video will describe the parts of an individual route, in particular the output that you see in the show IP route command. Now let's take a look at the scenario for this lab. There'll be three main steps. At the first step, the router has no dynamic routing protocol and no static routes, so it only has connected routes. Then at step 2, we're going to add a static route so that packets can be routed left to right through a sample network. And then at step 3, we'll see how to configure static routes so that packets can be routed right to left through the network. Now if we take a look at the topology for a moment, it's pretty simple. It's only two routers with three subnets. Each of the subnets uses a /24 mask just to keep the subnetting math easy. So we end up with three subnets. The LAN subnet on the left, which is subnet 11 if you will. The serial link subnet in the middle, which is subnet 112, focusing there on the third octet again. And then on the far right LAN, we've got subnet number 12 on the right. So let's begin by examining connected routes. For any router to add a connected route to its routing table, the router must have an interface with an IP address configured, and that interface must be in an up and up state. Each router interface has a state that's described by two words. If both of those words are up, it means that that interface can send and receive packets. So once the interface has an IP address and it's up and working, then the router adds a route for that connected subnet. For instance, here on router 1, notice it's got a subnet on the left on its LAN, subnet 172.22.11.0, or subnet 11 for short. So as soon as that interface is up, after being configured with the IP address shown there, R1 adds a connected route for subnet 11 and lists that off its FA00 interface, as you see there in the routing table. Then once R1's serial interface comes up, after having been configured with an IP address as well, R1 will add a connected route for the 112 subnet, as you see there in the second entry in R1's routing table. Similarly, R2 will add two connected routes as well. When R2's serial interface comes up, after it's been configured with its IP address, R2 will end up with a route to subnet 112, the first entry in its routing table that you see there. And then once R2's LAN interface comes up, R2 will add a connected route for that subnet, namely subnet 12, and show that it's listed off of interface FA00. Next, let's take a look at the connected routes on the routers. By looking at the output of the show running config command and scrolling down to the interface area, you'll see four interfaces, two LAN interfaces and two serial interfaces. Notice here that FA00 does indeed have an IP address configured, so there may be a connected route added on router 1 for that interface. FA01 though does not have an IP address configured, so there'll be no connected route associated with this interface. Then on the two serial interfaces, note here that both of the serial interfaces do indeed have an IP address configured. However, down here on serial 011, it has the IP address, but there's also a shutdown command configured on it, meaning that of course the interface won't be up. So we see three of the four interfaces have IP addresses, but only two of them are going to end up in an up and up state, as noted here in the output of the show IP interface brief command. Notice all four interfaces, the two fast Ethernet interfaces and the two serial interfaces, they're all listed. But if you look at the two right-hand columns, notice that the status and protocol are up and up on only two of the interfaces. In other words, only two of the interfaces have an interface status of up and up, namely FA00 and serial 010. So only two interfaces meet the requirements for adding a connected route. Now if we take a look at the IP routing table, because only two interfaces were both up and up, as well as having an IP address configured, there's only two connected routes here on router 1. Notice here in the legend at the top of the show IP route command output, there's a letter C meaning connected, And if you look at each of the two routes at the bottom of the output, you'll notice a C in the left-hand column, indeed meaning they are connected routes. Notice the actual subnets themselves are subnet 11 as the first route and subnet 112 as the second route. Just to be complete, let's switch over to router 2. Here on router 2, the output of the show IP interface brief command shows there are 4 interfaces, but notice that 2 of them are administratively down. 2 of the interfaces, namely FA00 and serial 010, are in an up and up state and have IP addresses configured. So we'll have 2 interfaces that meet the requirements for having their connected subnets added as connected routes to the routing table. If you look at the output then on router 2 of the show IP route command, you'll see those 2 connected routes show up. Notice the C in the left-hand column meaning connected routes. And in this case, we've got subnet 12 and subnet 112 in the routing table. Now notice there are 3 subnets in the picture of this network, but each of the routers only knows about 2 of those, the connected routes. R1 does not know about R2's LAN subnet, and R2 does not know about R1's LAN subnet. As it turns out, if PC1 tried to ping PC2 right now, the ping would fail. The reason is that there's a couple of routing problems in this network. Here at step 2, we'll take a look at the left to right packet flow, determine the problem, and fix it with a static route. First of all, thinking about PC1's logic, when PC1 wants to send a packet to a different subnet, like to PC2, PC1 simply uses its default gateway, in this case forwarding the packet over to router 1. When router 1 gets the packet that's destined to PC2, router 1 notices that it does not have a route matching PC2 as the destination address. So we'll need to add a static route as shown here. First of all, we'll add a static route that points to PC2's subnet, namely the 172.22.12.0 subnet, and we need to tell router 1 how to forward packets destined to that subnet. So we might tell the router, hey, put in a next hop IP address of router 2's IP address, namely 172.22.112.2, or we could have told router 1, oh, just send the packet out its serial 010 interface. Now once the packet arrives over router 2 already has a connected route to PC2's subnet, so router 2 already knows how to forward the packet. To configure that route in router 1, we're going to use the IP route global configuration command. In this case, we'll use the style of IP route command that uses a next hop IP address. Now, the first real parameter in the IP route command is the subnet number, along with the subnet mask as you see here. Together they define the destination subnet. In this case, we'll plug in subnet 12, or more specifically 172.22.12.0, with a mask of 255.255.255.0, which is the subnet on the right where PC2 resides. Then we'll point to the next hop IP address. Now, from router 1's perspective, that's router 2's IP address, specifically router 2's IP address on a common subnet. In this case, we'll point to 172.22.112.2, which is router 2's serial IP address. So, moving back to router 1, notice the output of the show IP route command confirms that router 1 does not have a route to reach subnet 12. It still only has the 2 connected routes. Now if we get into config mode, type the IP route command, plug in the subnet number 172.22.12.0, followed by the mask. That of course is the subnet in which PC2 resides. And then we want to tell router 1 the next hop IP address, just like we saw in the presentation, 172.22.112.2, which is router 2's serial IP address. After typing that command, if we get out and do the show IP route command again, we notice that there indeed now is a static route added to the routing table. Note the legend at the top shows S for static, and if we go to the left-hand part of the line for the new static route, there is an S, meaning it indeed is a static route. It references subnet 12.0, and it says to get there via 172.22.112.2. The via simply means that's the next hop router's IP address. By adding the static route on router 1, we've solved the problem of PC1 getting a packet over to PC2. However, if PC1 pings PC2 right now, the ping still fails. The problem isn't getting the packet from PC1 to PC2, it's getting the packet from PC2 back to PC1, the right to left flow in this network topology. So let's take a look at the right to left flow here in step 3. PC2, to send a packet back to PC1, is going to use its default gateway, namely 172.22.12.2, to forward the packet to router 2. Now router 2 is going to need a route that says, oh, to forward packets to PC1, let me send those packets to router 1 next. Now that route is the one that's now the third entry in R2's routing table that says to get to subnet 11, send the packet out my serial 010 interface to router 1 next. That'll be the route we add with the IP route command on router 2. When the packet gets over to router 1 needs a route to say to forward the packet onto PC1. That route already exists. That route is the connected route off router 1 for subnet 11. Now, if we take a look at the IP route command that we'll need on router 2, we'll use a different style IP route command just to show you the different command. The first part of the IP route command works the same as the one we saw at step 2. It lists the subnet number and subnet mask, which identifies the destination, if you will. Now, instead of listing a next-hop router IP address, this command lists an outgoing interface. For instance, in this case, we're going to tell router 2 to send packets to subnet 11, send them out your serial link, namely serial 010. So now let's take a look at router 2 for a moment. First of all, the show IP route command confirms that router 2 only knows about 2 connected subnets right now. So let's get into config mode and we'll add the IP route command. Notice the command starts with IP route. It lists 172.22.11.0 with a 255.255.255.0 mask, which describes the left-hand LAN subnet, the subnet where PC1 resides. Now in this case, notice the command lists serial 010 as the outgoing interface. This is R2's interface serial 010, telling R2 to send packets out that interface in order to reach subnet 11. Now getting out of configuration mode and doing the show IP route command again, we see there is indeed a new route in the routing table. Notice there's an S in the left-hand column, signifying that this route is indeed a static route. Notice it does list subnet 11 there as that static route. Now the output does differ slightly from what we saw on router 1 just a moment ago. Notice instead of a via followed by an IP address, it simply lists the outgoing interface, namely serial 010. It also lists this phrase that says, quote, directly connected. It's a bit of a quirk and a long story, but if you want to know if the route is a static route or not, just key on the code on the left, which of course an S stands for static, and this is indeed the static route added by the IP route command. Now at this point, because there are routes in both directions, PC1 can ping PC2 successfully. By viewing this video, you should be better able to explain the concept of a connected route and list the 2 requirements that a router has before it will add a connected route to its routing table. You should also be better able to configure the IP route command using 2 main styles, one pointing to the next hop router using the next hop IP address, and the other referencing the next router by simply referring to an outgoing interface to use to reach that next hop router. Along the way, you should have learned a lot about the components of a route in an IP routing table, so you should be better able to describe what's in a route, particularly what's in the output of the show IP route command.